In this video, we're solving problem 3.2.38 from the Essentials of Statistics text, 6th edition by Mario Triola. We're asked to find the standard deviation S of sample data summarized in a frequency distribution. Given the formula for the sample standard deviation, where X in the formula represents the class midpoint, F represents the class frequency, and N is the total number of sample values. And then we're also asked to compare the computed standard deviation to the standard deviation obtained from the original list of data values. And that or standard deviation, which is the more accurate sample standard deviation that is calculated using all of the data, that was 9.0. One thing I will say about this problem statement is that I think it would be better if they had worded it just a little differently. We're not actually able to find the true sample standard deviation using this formula. In order to find the true sample standard deviation, we actually have to have the list of data values. But we can approximate the sample standard deviation if we have this frequency distribution, which is just a summary of the data in our data set. And so what I'm going to do is I'm going to show you how to come up with this approximation of the sample standard deviation using this formula. I'll show you how to do it on paper, and then I'll also show you how to use Excel to do the calculations for you. Excel is actually a lot easier in this case. And then we'll talk about how we can compare the approximate sample standard deviation that we get using this formula to the actual sample standard deviation obtained from the original list of data values, which is 9.0. So I'm going to share my screen with you now, or actually share my piece of paper with you. So here's our problem statement, and here is the frequency distribution, but I've organized it differently. I wrote the data in columns rather than rows. So this tells us that rather than taking n and multiplying by the sum of the x's squared and subtracting the sum of the x's, since we don't actually have all those x values, meaning we don't actually have all of the data values on our list, but we have this frequency distribution instead, what we're going to do is use the class midpoint for each of these classes as an approximation of the value of each of the values in that class. So there were 25 values that ranged between 27 and 33 in our list of data. We're going to assume that all 25 of those are approximately equal to the class midpoint of that class. We're going to call this class midpoints X, and then we're going to take that X and multiply by 25 to say that the sum of all of the values in this class is approximately equal to that class midpoint added to itself 25 times, which is the same as taking the class midpoint and multiplying by 25. That's what we've got right there. And then over here in our sample standard deviation formula, normally we have the sum of the x's squared. Since we don't actually have the x's, we're going to take the class midpoints, assume that the class midpoint is approximately equal to all of the values in, or all of the values that are in that class. So we'll assume we've got 2 values that are equal to the class midpoint here, and we'll assume we've got 25 values that are approximately equal to the class midpoint here, and so on. Well, we're going to take all of those class midpoints and square them, and then multiply by the frequency. And that's going to be an approximation of the sum of the original list of values squared. So this is very similar to our sample standard deviation formula. We've just got frequencies here, and we're using class midpoints to replace the values that we don't have. So if I'm doing this on a piece of paper without using technology, the first thing I need to do is find the class midpoints. Those are our x values. And remember how we do that. The class midpoint is just the mean of that lower class limit and upper class limit. So you add those two together and divide by 2. Notice I get 23, which I think you could have probably guessed. What's the number halfway in between 20 and 26? It's 23. And then you could do the same thing here. You do 27 plus 33 and divide by 2. Or you could ask yourself, what's the number halfway in between 27 and 33? It's going to be 30. And then what's the number halfway in between 34 and 40? It's going to be 37, and so on. And if you want to check, you can add these two together. Let's do the 48 plus the 54. And divide by 2. And look, we still get 51. So those are the class midpoints. You add these together and divide by 2, or add these together and divide by 2. You get these. Or you can find that first class midpoint and notice that the class width is 7. So you can take this and add 7 to it to get the next class midpoint, and take this and add 7 to it to get the next class midpoint, and then the next one, and then the next one, and then the next one. So that's one way to look at it. Or you can look at these two numbers and then think about finding the average of those numbers. I know Mr. Triola would be mad at me for calling it the average. We want the mean of those two numbers. So we want to do this plus this divided by 2, or asking yourself again, what's halfway in between the 27 and the 33? It's going to be 30. Okay, so those are midpoints. That's what we're going to need right there. So we're going to have frequencies times those for right here. And we also need those class midpoints squared. So let's do the f times x. So this will be 46 and 750 and 36 times 37. Oops. Is 1,332. 44 times 15 is 660. 10 times 51 is 510, and 58 times 5 is 290. And then we also want the x's squared. So we'll have 2 squared is 4. Oops, that's the wrong one. That's the frequency. I want to square the x's. Sorry about that. I want this 23 squared. Uh, 30 squared, you could probably guess what that is without a calculator, I hope. 37 squared. 44 squared. 51 squared. And 58 squared. So those are the class midpoints squared. I want to take each of the class midpoints and multiply by the corresponding frequency to get an approximation of the sum of the squared x values in the original data set. So I want this 529 times the frequency, which is 2. And then the 900 times the frequency of that class, which is 25. Then that 1369 times the frequency of that class, which is 36. Then I've got 1936 times the frequency of that class, which is 15. Oops, now I put a log in there. There's 15. And then we want the 2601 times 10. Just going to move our decimal over 1. And then the 3364 times 5. Okay. All I need is to add up all of these frequencies times class midpoints. It's going to give me an approximation of the sum of all of the original values. I'm just going to call this column, or this row, excuse me, totals. So I'm adding these guys now. Again, this is something that's good to do with a friend, so you can check each other's work. Or just use Excel. As long as your data entry is correct, it'll be accurate. As long as your data entry and your formulas in Excel are correct, it'll be accurate. So now I'm going to add up the frequencies times x squared because I need the sum of those for right here. Okay, so I've got the sum of these and the sum of these. And now I need n. Now you might think that you don't have enough information here to find the sample size, but you actually do, because we had 2 values in this class and 25 values in this class and 36 values in this class and 15 values in this class and so on. So even if I don't know what these numbers represent, and unfortunately from the problem statement, I don't know what the numbers represent, but I know I had 2 values that were between 20 and 26, and I had 25 values between 27 and 33, and I had 5 values between 55 and 61. So if I want the total number of values, that's represented by n, our sample size, that's the same as the sum of the frequencies, because there's 2 values there, 25 there, 36 there, and so on. So I'll add those up. And I get 93. That's my n. I've got 93 times the sum of the frequencies times x squared, which is this, 144,712, minus the sum of the x's squared. That's normally the sum of the x's squared. In place of the sum of the x's squared, we've got the frequencies times the class midpoint, which is an approximation of the sum of the x's in that class and the sum of the x's in that class and the sum of the x's in that class all added together. And we got 3,588 approximately. We're going to square that. And then we divide by the sample size, which is 93, times 1 less than the sample size, which is 92. And this is how you do it by hand. I'll show you how to do it in Excel in just a moment. Now I want to do the numerator first. 93 times 144,712 minus 3,588 squared. That's my numerator. Divide by, open parentheses, 93 times 92, close parentheses. And then I want the square root of the answer. So I press the square root button on my calculator, and then I've got an answer button right there. Square root of the answer is this. So it's approximately 8.265, so 8.27. I'm not sure what decimal place they want me to round to. I bet it's just 1 decimal place. But let's look at it and see. Okay, round to 1 decimal place as needed. So that's approximately 8.3. And it likes it. Now I also want you to show, or I also want to show you how to do this in Excel. It's so much faster and easier in Excel. So we're going to open in Excel. There are my intervals. You still have to compute those class midpoints. So we're going to do 20 plus 26 divided by 2 is 23. Actually, I've already calculated those, so I'm just going to type them in now, just do a little data entry. Oops, that's 51, not 52. So these are my class midpoints. And then I want the class midpoints squared. So I'll take each of these x's and square them. I actually just square the first one, and then I drag and drop, and it'll square all of them for me. Pretty nice. Okay, now in this column, I want the frequencies times the x values. So I hit equals, choose the x value, times, that's an asterisk, times the frequency, equals this cell times this cell, hit return or enter, and then drag and drop. And then you want the frequencies times the x's squared. So hit equals, choose the first cell in the x squared column, times the first cell in the frequency column, hit equals or enter, drag and drop, and now you've got everything on here that you had over here. A lot less writing and a little bit more accuracy, provided that you calculated your class midpoints correctly, and then of course you had to type them in correctly. Now we need the sum of the frequencies times the x values. Sorry, I should have zoomed in a little sooner. I want the sum of those, so I will hit equals sum, and then grab all of those values in the column for f times x. Oops. Close parentheses. And I think I'll highlight this and highlight this just to remind myself that these are total columns. And then I want this total over here. Now you could do the same thing and hit equals sum, but you can actually drag and drop to the right as well, and it calculates it that way. Okay, so now I want to use that formula for the approximation of sample standard deviation, which is equal to the sample size. Oops, let's calculate the sample size. Remember, that's the sum of the frequencies. 93, good, that's what I got when I did it by hand. So we want equals the sample size times the sum of the frequencies times x's squared minus the sum of the frequencies times x's, where x's are the class midpoint. And then you actually have to square that one. That's the numerator. Here I want to take that numerator and divide by the product of 93, which is my sample size, and 92. And then I want the square root of that answer, so I'll hit equals square root of the answer. So I select the cell, D12 in my case, a close parentheses, and I get 8.265. And I got 8.27 over here, so that's good. In Excel, we get exactly the same thing. And that's not cheating. Some students think it's really cheating to use Excel for this. You're not being tested on arithmetic, you're being tested on your ability to apply this formula to this data. As long as you understand what this formula says and you're able to get Excel to do it, that means you know what you're doing. So don't feel like you're cheating if you use technology. We're not cheating when we use technology in statistics class. Okay, let's go back to that question. So I'm right over here. Okay, and the question says, consider a difference of 20% between two values of a standard deviation to be significant. How does this computed value compare with the given standard deviation of 9.0? Okay, so we want a difference of 20%. We want to see if the difference is greater than or less than 20%, given this approximate sample standard deviation of 8.3 that we just calculated using this formula for data given in this summary form in the frequency distribution. And we want to compare that to the actual sample standard deviation of 9.0. So I'm going to share my paper with you again. And then remind you of how percent error works. Whenever you're calculating the percent error of something, you want the actual quantity minus the approximate quantity, the quantity that you're comparing it to. And so that's going to give you an error. You want to compare that to the actual quantity. You're thinking of that as your baseline, and that's going to give you a proportion. If you want percent error rather than relative error, you take that and you multiply by 100%. We can do these, we can compute this with approximations of sample means like we did in lesson 3.1. We're doing it here with sample standard deviation. But this percent error formula and this without the 100% relative error formula is standard. It's something that we use outside of statistics class as well. So we want the actual standard deviation right there, which is 9.0. And we're going to subtract our approximation, which to one decimal place was 8.3. And we want to divide by the actual and then multiply by 100%. So I've got 9.0 minus 8.3 divided by 9 times 100, and I want a decimal. So I get about 7.77777, infinitely many sevens, %. So that is the percent error. Now let's go back to our question. Oops, sorry about that. I don't know why that window disappeared. That's okay. The question says, consider a difference of 20% between two values of standard deviation to be significant. Well, we just calculated the percent error. That difference is 7.8% approximately. The question says, how does this computed value compare with the given standard deviation, or the calculated standard deviation using the original sample data of 9.0? Well, the difference between them was only 7.8%. That's definitely less than 20%. So C says the computed value is not significantly different from the given value. And let's read this statement again. It says, consider a difference of 20% between the two values of standard deviation to be significant. Since the difference was only 7.8%, that's not significant. So it doesn't say it's significantly greater. Well, actually, it says, is the computed value significantly greater, or is it significantly less? Well, it's a little bit less, but it's not significantly different. So let's see if it likes this answer. Okay, yeah, that's exactly what they wanted. Because the difference was not more than 20%, we said that's not significant. 7.8% difference is no big deal. That's to be expected.